So if we're going to explain how the hydrophilic and hydrophobic structure of phospholipids maintains the membrane, it's a good idea to look at the intricate structure of the phospholipids. So a phospholipid, if you're looking on the right here, is made up of a phosphate head, which is polar and water soluble. It has a glycerol in the middle, and the phospholipid also has two fatty acid, what we call tails, and these are non-polar and therefore not water soluble. Now if we look at the model, that's often the way it might be represented. Certainly in my diagrams you'll see it represented this way. The head is hydrophilic. I just mentioned that it is polar and water soluble. Hydrophilic is like water loving. And the tails, these are hydrophobic, as again I just mentioned that they are non-polar, not water soluble. Hydrophobic is like water hating. So as a result of this structure of the phospholipids, you find that the phospholipids in the cell membrane orientate themselves as a bilayer. The hydrophobic fatty acids tails pointing inward and the hydrophilic phosphate heads pointing outwards, and this forms a water-free zone in the middle right here. And the phosphate heads are pointing outwards because in each case you either have the extracellular fluid or you have the cytoplasm. Both of these, their main component is water. So the interesting thing about this is that the tails of the phospholipid do not really attract one another, and this allows for a certain fluidity of the membrane. So if the membrane encounters a disturbance, as I'm simulating here, although the components may temporarily move apart, the phospholipids will reorientate themselves in the bilayer that they formed before, with the hydrophobic fatty acid tails pointing inwards and the hydrophilic phosphate heads pointing outwards, and this maintains the structure of the cell membrane.